Day 14 of 75, and today we're turning hashmap and string into interview weapons. Here's the trap most Java devs fall into. You reach for nested loops when a hashmap would cut your complexity from O of n squared down to O of n. Or you concatenate strings inside a loop and quietly create O of n squared garbage collector pressure. By the end of these 5 minutes, you'll have a decision tree for every string plus hashing problem you'll ever see. Let's build solutions that actually exploit Java's guarantees. We start cold with group anagrams, LeetCode 49. Naive instinct. For each word, sort its characters and use that as a key. In Java, that's arrays.sort on s.to-char array, then new string of those chars, dropped into a hash map of string to list of string. It works. You group every word whose sorted form matches. But profile it. Sorting each word is O of k log k, and you pay that for all in words. On long words or huge inputs, that log factor is the bottleneck nobody notices until it's slow. Here's the refactor. Anagrams share the same letter counts, so build a frequency fingerprint instead of sorting. Allocate an int array of size 26. Walk the word incrementing count at c minus lowercase a, then encode that array into a string key. Something like count plus a separator per letter. Now your key costs O of k, not O of k log k. The rule: use the sort key when k is small and readability matters. Switch to the int 26 fingerprint when words are long or you're on a hot path. Same hash map, cheaper key. Now pivot to the pattern this generalizes into: sliding windows. Longest substring without repeating characters. The clean approach uses a hash map of character to integer, storing each character's last seen index. As you scan with a right pointer, when you hit a repeat, you jump the left pointer. I equals math.max of I, map dot get of c plus 1. That math.max is the whole trick. It stops you from moving left backward on stale entries. Compared to the naive hash set approach that removes one char at a time, on input like abcabcab you save real iterations. Let's talk map mutation, because this is where Java discipline shows. For minimum window substring, you keep 2 maps, need versus window, plus a formed counter for satisfied characters. When you shrink from the left, you want map.merge of c, -1, integer : sum, clean decrement with no null pointer risk. Reach for get or default when you only read, merge when you combine values, and compute if absent when you're building nested structures like a map of lists. That last one kills the if null then new array list boilerplate entirely. When your alphabet is fixed, drop the map completely. Ransom note, LeetCode 383. Can you build the note from the magazine letters? Use a single int array of 26. One pass over the magazine to increment, one pass over the note to decrement, and check. If any count goes negative, return false. No boxing of characters, no hash computation, and the array sits cache-line friendly in memory. The hashmap version only earns its keep when the text is real Unicode, and 26 slots won't cover it. One more performance note on strings themselves. String.charat in a tight loop is fine, but if you're transforming, don't concatenate with plus inside the loop. Every plus allocates a new immutable string, and you're back to O of n squared. Use String Builder. And for text beyond basic ASCII, CodePoints gives you a stream that handles surrogate pairs correctly, so emoji and extended characters don't silently break your counts. Immutability is a contract. Respect it, don't fight it. Here's your decision tree, the thing to carry into mock interviews. Every string plus hash problem falls into 3 buckets. 1. Frequency counting. Use int 26 for bounded ASCII, a hash map for Unicode. 2. Windows, 2 pointers plus a map tracking what's inside, with the last seen index jump. 3. Exact match or grouping, canonical form, either a sorted key or a frequency fingerprint. Name the bucket first, and the data structure picks itself. That's the difference between flailing and solving cleanly under pressure. Day 14 done. The takeaway: hashmap gives you O of 1 amortized, but Java mastery is knowing when int 26 beats it on boxing and cache cost. Subscribe for day 15.